Good morning, my dear students. My name is Neer Twaena. Currently, I'm available at the Hamlet Tuition Center, Brahmatul, Kathmandu, and Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 10, this is your science class, and in our science class, we have been discussing about the lesson electricity and magnetism. Well, we have come almost to the end of the lesson. Okay, not the end, but almost to the end. We still have 2 more classes remaining. Well, today we will be discussing about transformers. Well, transformer is an electrical device that converts low voltage high current AC to high voltage low current AC, or vice versa. Well, what does it mean? Let us go through this example once. This is a hydropower station. Yes, in hydropower station they have a generator, isn't it? A hydroelectric power plant has a generator, and that generator is capable to produce current electricity at 11,000 to 25,000 volt. Okay, that generator, the generator placed in the hydropower station is capable of generating current at 11,000 to 25,000 volt, and the current which is produced in hydropower station, it is consumed in very far away place in cities and industries which are very much far from hydropower station itself. And if you transmit electricity at the same voltage, then large amount of electricity would be lost due to the resistance of wire used in transmission. Okay, due to the resistance of wire used in transmission, large amount of current would be lost in the process of transmission. Okay, you might have heard about MCC recently. Yes, what is the main project of MCC? It is the improvement of transmission line so that loss of current electricity would be minimum, isn't it? It is the same thing. Yes, okay, so before transmission, this current voltage of the current must be increased. Okay, higher the voltage, higher the potential difference, less will be the loss in transmission. Okay, that's why the current generated from the hydropower station is passed through transformers. This special device, okay, this is very large equipment, isn't it? So the current produced from hydropower station is transmitted through this special device. This special device increases the voltage of current to up to 760,000 volt, very high power, isn't it? Then after increasing the voltage of that current, the current is then transmitted through the transmission line. You have seen such transmission lines in several places. Yes, in such transmission lines the current flows at how much volt? 760,000 volt. After the current is passed through transmission line, the current is reaches to the city station. Okay, city station. The city station also has this special kind of device. Okay, city station has this special kind of device which receives the current at 760,000 volt. Okay, which receives the current at 760,000 volt, and it gives out the current at 12,000 volt. See, the potential difference of voltage has been taken down. The voltage has been taken down from 760,000 to 12,000 volt. Now the current after passing through the city station will pass to the local transformer. You might have seen such transformers in your locality. Okay, nearby your house, in your locality. Every locality has such transformers. Yes, and such transformers, they receive current electricity at 12,000 volt, and they give out the current as 220 volt. And that 220 volt current, is then transmitted to or supplied, distributed to your house. Understood? Okay, so in this entire process, we have talked about converting or changing the voltage of current. Yes, in the first example we talked about increasing voltage of current, that means low voltage high current, conversion of low voltage high current. Remember, I is inversely proportional to V. Okay, that you studied in grade 9. I is inversely proportional to V. So high voltage means low current, low voltage means high current. So this low voltage high current is converted by this device into high voltage low current. Okay, so this device, according to our definition, this device is a transformer. Understand? This device is a transformer. Okay, so and similarly this device does not alter the current. Yes, 760,000 volt, and same here. Okay, this device is not a transformer, this is simply a transmission line, this is simply a tower, okay, which supports the wire, that's all. Okay, so this device however converts the voltage from 760 volt to 12,000 volt. This device converts 760 volt into 12,000 volt, means this device converts high voltage low current into low voltage high current. Okay, high voltage low current into low voltage high current. So this device by definition is also a transformer. This device is also a transformer. Similarly, look at this device. This device also converts 12,000 volt into 220 volt. Are you getting or not? Yes? Okay, so this device also converts high volt low current into low volt high current. Okay, so by definition this is also a transformer. Okay, I hope you understand what a transformer is. Transformer is an electric device which converts voltage of current. Transformer is an electric device which converts voltage of current, either from low voltage to high voltage or from high voltage to low voltage. Yes, in the first example the current is being transformed from low voltage to high voltage. A voltage of current is increased by this transformer, whereas voltage of current is decreased by this transformer and further decreased by this transformer. Okay, so this type of transformer which increases the voltage of current is called step up transformer. Step up transformer. Okay, shall I write it here? Okay, got it or not? This kind of transformer which increases the voltage of current is called step up transformer. Okay, this is called input voltage, this is called output voltage. So if output voltage is greater than input voltage then it is called step up transformer. Similarly, in this case we can see the input voltage is greater and output voltage is lesser. Okay, the voltage has been taken down by this transformer. Okay, so this kind of transformer is known as step down transformer. Okay, the transformer which decreases the voltage of current is called step down transformer. Okay, and here this transformer also does the same thing. Okay, it also decreases the voltage of current. See, input voltage is 12,000 and output voltage is 220. So this transformer is also called step down transformer. Okay, now you understand the concept of transformer and the concept of step down transformer and step up transformer. Okay, what are the types of transformer? Step up and step down. Any confusion? Well, regarding this example, there is a question which is very frequent, okay, which is very important as a concept. Use of electricity would be limited without the invention of transformer. Justify. If the transformer was not invented, then what would happen? What would happen to our modern world, which uses electricity to such a great extent? See, no transformer means this one is not there, okay, this step is not there. No transformer means that, isn't it? Okay, there are no transformers, this is not there. So instead of 760 volt, current would be transmitted at 25,000 volt itself, okay. So at that voltage, lots of current would be lost in the process of transmission, isn't it? And no transformer means this step also won't be there, and there won't be this step as well. So what voltage of current will you get at your home? Directly you will get 25,000 volt. Now what happens to your circuit and devices if you receive 25,000 volt of current? It would be a huge disaster, isn't it? That is why transformer is essential. Transformer is essential. Now see, it would be impossible to generate electricity at exact voltage as required. See, we need current at 220 volt. So it won't be possible to generate the current at 220 volt at the hydropower station. And if you manage to generate current at 220 volt, then imagine this, how much electricity will be left out when it is transmitted to your home, because 220 volt is such a small voltage, isn't it? At such small voltage, most of the current would be lost within the transmission line because of resistance of the wire, okay. So virtually no current will reach your home, or you have to build your home near the dam. Will that be possible? Okay, anyway, see, this is the point. It would be impossible to generate electricity at exact voltage as required. Even if it becomes possible, it would be difficult to calculate the loss of potential over long distance transmission. The invention of transformer resolves all those obstacles. Given an example, power is generated at a power house at around 11,000 to 25,000 volt. It is stepped up at 760,000 volt before, okay, V and 0 seems the same, okay, before transmitting over long distance. Electricity loss would be minimum at high voltage. At city substation, the voltage is taken down to 12,000 volt and supplied into area transformer, or also called local transformer, okay. The current is then stepped down to 220 volt. Any confusion up to here? Okay, if there are no confusion, then we should go to the next title, working principle of transformer. Okay, let us continue with the working principle of transformer. Well, the transformer works on the principle of mutual induction. Now what does it mean by mutual induction? What is mutual induction? Okay, let us recall what we studied in our previous class, okay. Electromagnetic induction. What do you mean by electromagnetic induction? Do you remember it or not? Well, let me go to the page, okay. Let me go to the page regarding electromagnetic induction. Let's see, okay. No. Okay, here. Do you remember this or not? Or do you remember this diagram? What we said that this is a magnet, isn't it? This is a magnet. And when you move the magnet through the solenoid, what happens? When you move the magnet through the solenoid, what happens? The magnetic flux linked to the solenoid changes. Yes, the magnetic flux linked to the solenoid changes, and as a result EMF is induced in the solenoid. Yes, the magnetic flux linked to the solenoid changes, and as a result EMF is induced in the solenoid. So what causes electricity to be induced in the solenoid, in the wire? It is the change in magnetic flux, or change in magnetic flux linked to the coil or linked to the solenoid. Okay, it is the change in magnetic flux linked to the solenoid that causes a flow of a generation of electricity, or you can say induction of electricity. So same principle is applied here. So this is a solenoid, yes, the primary solenoid, which is connected to the source of electric current. Okay, the source of electric current is connected to this solenoid, so that circuit is completed like this. See, the blue wire, through the blue wire shows the primary circuit of the electricity. Okay, so when current is passing through this circuit, then what happens? This solenoid becomes a magnet. Yes, this solenoid becomes a magnet. Let's say at first this pole acts as plus and this pole acts as minus. Okay, minus. This pole acts as, or this terminal acts as minus. Then in that case, let us say that through the by transmission of current, say this pole, this side of magnet becomes north pole, and this side of magnet becomes south pole, isn't it? Then what? A magnetic field is produced, isn't it? This black line indicates magnetic field. Okay, that's okay. Okay, this black line indicates the magnetic field. Now see, the red solenoid is under the magnetic field, is inside the magnetic field of blue solenoid. Are you getting me? The blue solenoid has become what? It has become electromagnet. Okay, the blue solenoid has become an electromagnet. Okay, so since it has become an electromagnet, it produces a magnetic field. Okay, so when the magnetic field is generated, this solenoid, now see, this solenoid is inside the magnetic field of this electromagnet. Understood? Okay, so since we have connected the electromagnet, this transformer, to AC source, what happens in next phase or next circle, the polarity changes. Okay, this pole becomes minus terminal and this pole becomes plus terminal. In that case, the direction of current flow would be altered and the polarity of magnet would also alter. Yes, so this pole becomes north pole and this becomes south pole, and that is equivalent to rotating of magnet, isn't it? That is equivalent to 180-degree rotation of magnet. Yes, in that case the magnetic field would alter. It is similar to rotation of magnetic field. Yes, okay, previously, let's see. Okay, previously the magnetic field was running in this direction. Look at the arrow. The magnetic field was running in this direction, isn't it? But later on, when the polarity of current, AC current changes, the polarity of AC current changes, then the flow of current in the solenoid also changes. Yes, that changes the polarity of electromagnet. Okay, then the magnetic line of force also changes. It reverses. See, so this one cycle is equivalent to 180-degree rotation of solenoid. Yes, that means the magnetic flux linked to this red solenoid is changing. And what happens when magnetic flux linked to a solenoid changes? EMF is induced. Understood? EMF is induced. So in this solenoid, new EMF is induced. EMF is induced. Okay, this is a main principle of transformer. Okay, so when you use a transformer, actually the same circuit current is not flowing to your device. Okay, it is the new current generated by this secondary coil, this solenoid. Understood? Now this process is known as mutual induction. Mutual induction. In it, why is it called mutual induction? Because of current it becomes electromagnet. Okay, magnetism is induced here, and because of induced magnetism in blue solenoid, current is induced in, or EMF is induced in red solenoid. That's why it is called mutual induction. Okay, magnetism is induced in one of the solenoid because of AC. Yes, because of AC, magnetism is induced in one solenoid, and because of magnetism, AC is induced in another solenoid. AC causes induction of magnetism, and magnetism causes induction of AC. That is why it is called mutual induction. Understood the principle? Okay, I hope you do understand this. Yes. Okay, now see, now let us discuss the structure of transformer. Well, here you are shown a picture of transformer, a real transformer which is used in our house in several devices. Not a big transformer in our local transformer or city station or powerhouse. They are much bigger. Okay, they are much bigger. This is a small transformer used inside the devices which are used in our homes. Okay, now the outer case, this is the outer case. Yes, if you remove the outer case, it looks something like this. If you remove the outer case, it looks something like this. And in here you can see several iron plates. Especially these iron plates are cut in the shape of E. Okay, it's like this. Okay, and the middle hand of E is inserted into the coil. Yes. Okay, so this part is known as core of transformer. Okay, this part is known as core of transformer. And see, there are two set of coils separated by insulator. Yes, insulating plastic, isn't it? There are two set of coils. The one set of coil is known as primary coil, and the second set of coil is known as secondary coil. And as I have already discussed just now, the primary coil acts as an electromagnet, or magnetism is induced in primary coil because of AC. Okay, and because of that altering polarity of magnetism of this primary coil, alternating current or EMF is generated or induced in secondary coil. This is primary coil, this is secondary coil. Understood? This structure is very simple. This structure is very simple. Now the simplest representation of transformer would be something like this. This is the core. Yes, core is represented simply by a rectangle. Okay, this is a core, and one of the hand of core in primary coil is winded. Yes, and this primary coil is connected to source of electricity. Understood? Now the voltage of input current is indicated by V1, and the amount of input current is indicated by I1. Okay, current is supplied to primary coil, and because of that supplied current, the primary coil becomes what? An electromagnet. Okay, and under the influence of electromagnet, AC is induced, EMF is induced in secondary coil, and that secondary coil is wound up in another hand or another side of the core. Okay, and that secondary coil is actually connected to load. Load means device. Okay, the current produced by secondary coil or the current induced in secondary coil is indicated by I2, and the voltage of the current induced in secondary coil is indicated by V2. Understood? This much structure. Okay, copy it. Okay, let's see. The note: a transformer consists of a laminated core made up of soft iron. The core is laminated with shellac or varnish. Now here is the point. Why is the core not made up of solid piece? It is not made up of solid piece. As you can see, several stripes are connected, are attached to form the core. Instead of using such several stripes, why don't they use a single piece of solid iron to make the core? Okay, in that case what happens? Addis current occurs. Addis current means, see in this simplified diagram once again. Well, this coil becomes an electromagnet, yes, because of AC, and under the influence of altering polarity of this magnet, EMF is generated in this coil. But the same can be said for this solid core as well. The core is also made up of iron or the conductor material. Yes, the core is also made up of conducting material. So EMF is induced in the conducting material, iron core as well. Okay, but if you use a solid piece of iron core, then the current induced inside the iron core will have nowhere to go but circulate within itself. The current induced in iron core itself will circulate within the iron core itself. It does not make circuit to anything else. Okay, so that is just like short circuit. Yes, when current is flowing within the same object, that means source of electron and the dump of electron are the same object, then in that case that electrical energy is converted into heat energy. Okay, that because of that current, the current which is circulating within the core, because of that current it will produce a lot of heat energy, and that current is known as Addis current because it was discovered by the scientist Addis. That current is called Addis current, and due to Addis current the transformer core become overheated and lots of amount of electricity is lost in the form of heat energy. That reduces the efficiency of the transformer. Okay, that's why what they do, they will use several small pieces of stripe. Okay, several small pieces of stripes here, and they combine these stripes, they attach these stripes by using a glue like material called shellac or varnish. Shellac or varnish. This shellac or varnish, they are actually thermosetting plastic, okay, which are insulator, and they do not melt by heating. They become even harder by heating. Okay, that's their ideal material to laminate the core of transformer. Okay, so that the current produced within a stripe won't have to flow throughout the core. Okay, it will flow only within the stripe. Okay, so one stripe is insulated from other stripe by using shellac or varnish, isn't it? That's why the current induced in one stripe will not transmit to another stripe. In this way, amount of current induced within the stripe can be reduced. Okay, and Addis current will be minimized, and overheating of the core can be prevented, so that efficiency of transformer can be maximized. Okay, see, remember this word. Okay, shall I make it red? Okay, shellac, red. Okay, shellac, red. Varnish, red. Not both, either one. Okay, a transformer consists of a laminated core made up of soft iron. The core is laminated with shellac or varnish. It has two coils of insulated copper forming two distinct circuits. I told you that, yes, primary coil and secondary coil, and both of them form two distinct circuits. Primary coil form primary circuit, secondary coil forms secondary circuit. Okay, another coil is circuited with the device. Okay, sorry, one of the coil is circuited with supply of AC, which is called primary coil. Primary coil is circuited with supply of AC, yes, and another coil, means this coil, is circuited with the device to be operated, also called load, yes, which is called secondary coil. Now you understand all the terms. Okay, the ratio of number of primary coil and secondary coil is maintained based on ratio of input voltage and output voltage. There is how many number of primary coil and what number of secondary coil should be placed, that is determined by amount of input voltage and output voltage. Okay, if you need to increase the voltage, you need to increase secondary coil. If you need to decrease the voltage, you need to decrease secondary coil, or you need to increase primary coil. Okay, that we will study within a few minutes. Okay, now see the next point. The core of transformer is laminated with shellac or varnish. The core is laminated to prevent it from overheating due to Addis current. Okay, Addis current is also, I'll make it red. Okay, Addis current causes loss of electricity in the form of heat. Any confusion up to here? Okay, if there are no confusion, then we should go to types of transformer. This we have already discussed, isn't it? Okay, there are two types of transformer: step up transformer and step down transformer. Well, step up transformer, it converts low voltage AC into high voltage AC. We have already discussed this, yes. It has higher number of turns in secondary coil than in primary coil. Look at this figure. This is a diagram of step up transformer. How many numbers are shown here in primary coil? 1, 2, 3, 4, 5. Yes. Now in secondary coil, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 coils are shown in secondary coil. See, in step up transformer, number of turns in secondary coil is higher than primary coil. Okay. Okay. Next point, it increases voltage of current by decreasing amount of current. Okay, when a transformer increases voltage, then the amount of current is decreased. Okay, like if it is supplied with, say, 5 ampere of current at 110 volt, and it gives 220 volt current, means it gives only 2.5 ampere current. See, the amperage is reduced whereas voltage is increased. Okay, the amperage is reduced and voltage is increased. Understood? Step up transformer increases voltage of current by decreasing amount of current. Okay, where is it used? We have discussed it in our first page. Yes, it is used in hydropower station to increase the voltage for transmitting electricity at low voltage. High current would cause loss of electricity over long distance transmission, so it needs to be stepped up as much as possible. Again, confusion up here? Okay, if there is no confusion, then let us go to step down transformer. The transformer that converts high voltage AC into low voltage AC, just opposite. Yes, it decreases voltage. It's called step down transformer. Start taking note. It has lower number of turns in secondary coil than in primary coil. See, the number of turns is just opposite in case of primary and secondary coil. Step up and step down transformer. Yes, in case of step up transformer, there are more coils in secondary coil. In case of step down, there are more coils in primary coil. Yes. Okay, it decreases voltage of current by increasing amount of current. Once again, if you supplied 2.5 ampere of current at 220 volt, then it produces 5 ampere of current at 110 volt. See, voltage as the voltage decreases, current increases. Okay, this is also just opposite of step up transformer. Yes, where it is used at city station and local station to step down the voltage of current successively before supplying to the household. Do you understand why is it called successively? Because first the city station lowers the voltage from 760,000 down to how much? 12,000. Is it 12,000? Okay, 12,000, and then the second transformer steps it down from 12,000 to 220, isn't it? So it is used to lower the voltage successively. And in household also it is used in many devices that operates at potential difference lower than 220 volt. Like your television, the television normally operates at 24 volt, but your current is 220 volt. So how to operate a television? If you open up the television, inside it you can find a transformer. You can find a transformer which converts 220 volt into 24 volt. Okay. Now the last thing we have to do for today is numerical, and for doing numerical you need a relationship between number of turns in coils and resulting potential. As I already told you that how many number of turns are needed in primary coil and secondary coil is dependent on ratio of input voltage and output voltage. Okay, because the ratio of input voltage to output voltage is proportional to number of turns in primary coil and secondary coil. It says proportional, does not say equal. Okay, it means the ratio is equal, but it does not say that input voltage equals to number of turns in primary coil. No, that is not it. Okay, what is it? Only the ratio between these two terms and ratio of these two terms are equal. Only the ratio are equal. Okay, such condition is known as proportional. So you get the formula Vp by Vs is equals to Np by Ns. Easy to remember. माथि पनि p छ, यसमा पनि माथि p छ, यसमा तल पनि p छ, तल यसमा पनि p छ र यसमा पनि सरी तल दुवैमा s छ, माथि दुवैमा p छ. याद गर्न सजिलो भयो नि. Vp by Vs equals to Np by Ns. सजिलो छ है. हो, यसैबाट अरु फर्मुला पनि डिराइभ गरिएको छ. 4-5 वटा फर्मुला छन् यसै रेशियोको. तर म के सजेस्ट गर्छु नि, अरु फर्मुलातिर नजानु, एउटै मात्र फर्मुला याद राख्नु. Okay? Okay, question number 1 of numerical. Well, I'm going to do only one numerical. Okay, rest of the question you have to do on your own. Okay, let's write given information. A power transmission line feeds input power at 2400 volt. Input power means what? Primary voltage. Yes, primary voltage, or you can also write input voltage. Doesn't matter, whichever is comfortable to you. Okay, primary voltage, it is indicated by Vp. Okay, Vp is given at 2400 volt, and then output volt / secondary voltage is also given. Read the question full. Look here, to a step down transformer with a primary winding 2000 turns, what should be the number of turns in secondary coil to get the output of 220 volt? So output is 220 volt, 220 volt, this much, and then number of turns in primary coil, that means Np. Is it given? With a primary winding of 2000 turn, it is also given as 2000 turns, and then number of turns in secondary coil, that means Ns. It is given? No, it's not given. Okay, this much is the given information. Okay, now see, we are going to use this formula. Okay, as we know, I am going to copy the formula right from here. Control C V. Okay, so I need to change the page. Let me do this. Let me go to the next page. Or what informations are given? PP is given. Okay, simply substitute the values. Okay, VP is given. Instead of VP, how much? What you should write? VP is 2400. Yes. V. Okay, volt. VS is also given. VS equals to 220 volt. NP is given. NP is 2000, and NS is not given. Okay, so by cross multiplying, you should get 2400 into NS is equals to 2000 into 220. Understand this? Cross multiplication. NS is multiplied to numerator of left side, 220 volt is multiplied to numerator of right side. Now you need to find out the value of NS. That means you need to remove 2400 from left side. How do you do that? NS equals to, okay, it will be divided in the other side. Yes, NS, it will be like 2000 multiplied by 220 by 2400. Okay, will it give you the final answer or not? Okay, multiply this, how much you get? Okay, 2000 multiplied by 220 divided by 2400. Okay, 183.3, but the number of turns cannot be in decimal. Okay, 183.33, so its complete turn would be 184. Therefore the secondary coil must have 184 turns. Okay, any confusion? Okay, I hope there is no confusion in doing this numerical, because this is perhaps the simplest numerical, okay, in your whole lesson, in your whole book. Okay, now what you need to do is take the assignment for today, similar types of numericals. All these 5 numericals are similar to this one. Okay, you should be able to do it. Now pause the screen, take the question. Okay, that much for today. I hope you have already taken the questions for assignment. Okay, submit this today. Okay, don't wait for another day. There are just 5 questions. It should not take more than 20 minutes. Okay, submit this today. Okay, this was for today. In our tomorrow's class, we will be discussing about power consumption in a house. Okay, or household power consumption. That is also numerical. So keep your calculator ready. Okay, until then, thank you class.